my name is Carlos Correa. I am an iOS engineer at FARFETCH, and welcome to the very first episode of FARFETCH MOBCAST, a series of videos to share our findings with the mobile community. Co-hosting this episode, we have Francisco. Say hi, buddy.
And I am Francisco Amado, also an iOS engineer at FARFETCH. In this episode, we will talk about the routing strategy used in the FARFETCH iOS app. Routing has different meanings depending on the technology that we are using, but in general, it represents a clear, simple pattern for navigating from one area of the app to another. This is a topic that causes a lot of discussion in the iOS community, but it's hardly a solution that fits all problems.
It is very important to have a well-structured routing mechanism because it allows us to create abstractions to separate features and reuse the code responsible for navigating between them. So today, we'll go through the routing strategy that we use in the FARFETCH iOS app and what made us get here in the first place. We will also guide you step by step on how to implement such a simple and robust solution.
In 2015, FARFETCH launched the first iOS app into production. At the time it was all Objective-C, although we had been adopting Swift in our tests. Apart from minor improvements, our router only had two major versions. Each of these versions was built to adapt it to our architecture requirements. Our first iteration was already a all-seeing eye singleton that managed all our navigations. These singleton functions received a string identifier and a collection of parameters to configure the destination view controller. Clearly, the approach was not flexible enough for a fast-paced growing app, where new view controllers were being created and existing ones were changed frequently. This string and collection-based approach was not very clear, as we never knew exactly what requirements each view controller had.
At the very beginning, we were 6 engineers, but as the years went by and the team scaled in numbers, our app architecture had to be overhauled in order to support our growing demand. So we took the decision to migrate to a distributed architecture. And because of this, we felt the limitations that a conventional navigation strategy has at such a higher scale.
As we were splitting our features into single modules, we used CocoaPods to maintain a private spec repository of our own private frameworks. This meant that each feature was being hosted on its own repository, not allowing dependencies to know each other directly. This also meant that we couldn't just explicitly use the classic navigation strategy that is commonly proposed by Apple documentation. Normally, for navigating between two view controllers, we end up creating a tie coupling by initializing the destination view controller in the original view controller, and finally using the UI navigation controller to push the target into the navigation stack. Tie coupling also happens when a class A knows too much of a class B, which means that changing the class B interface will force you to change the class A implementation.
This is an example where we couldn't keep this relationship if we wanted to separate features into their own modules. Once the link between those features no longer exists and they don't have access to one another, we have to somehow represent this relationship without reintroducing the coupling and keeping it flexible enough to use these new navigations in other places as well. We've built a sample app to showcase this navigation problem, and later on we are going to refactor this into our current strategy. So let's run the app and take a look on how it behaves. The Go to Listen button will push to the listen screen, and by selecting any item on the list, it will perform another push to the Details screen. We can also go from the main screen to the Details screen by pressing the Go to Detail button. Let's open the Xcode project to take a better look. Inside the root view controller, when the user taps in both Go to Listen and Go to Detail buttons, we create instances of Listen view controller and Detail view controller, which creates the coupling we want to avoid. You can see that happening in the lines 26 and 32. Moving on to the Listen view controller, the same happens when we select a table view cell on line 32, where we directly create an instance of Detail view controller just as we did before.
So how did we manage to get rid of such coupling? Was actually to leverage Swift protocols in order to describe our navigation interfaces. By centralizing all the navigation rules in one lower layer, where we describe the navigation protocols, we are able to share navigation between modules of the app, giving us the opportunity to actually reuse and recycle our code. One other benefit of using this protocol-based approach is that all the navigation code will be testable, as this routing mechanism is injected into the view controllers, which is easily replaceable by mocks. This way our app will work as the central coordinator, moving the logic of initializing, configuring and pushing new view controllers into the stack. This provides us with the base ideas for starting to migrate the way we route between screens in the sample app that we showed, and finally get to the approach that we want to end up with. The initial step to create a navigation layer between view controllers starts with describing the navigation protocols. Let's demonstrate this with a navigation to a detail page. First, we need to add to our project a new Swift file named detail navigation. As we are going to deal with view controllers, we can import the UIKit framework and create a protocol named detail navigation. Now let's describe the possible entry points to the detail screen here by defining a function navigate to detail that receives an identifier of an int type.
Next step is to use this navigation inside the root view controller. And for this, we will inject the navigator in the view controller's init. We will also hold a reference to the navigator by declaring an unknown property. So let's do this. Init navigator of type detail navigation. Let's hold this reference. Self navigator takes the navigator. Of course, this property does not exist, so let's create this right away. Private unknown let navigator of type detail navigation. Detail. Okay. And let's call the super init for this. Let's use this one. New. Okay. And now we need to delete the old navigation that uses the navigation controller and replace it with the injected navigator instance. Just down here, line 43 and 44, let's delete this and call self.navigator.navigate to detail and pass in the previously used 5 ID here. And let's compile the app. And since we've changed the root view controller initializer, Xcode now gives us an error in the scene delegate file. So we'll need to inject this class that conforms to the navigation protocol. And for this, let's create a class named router. New file, Swift file, router, okay. As we're going to deal with UIKit stuff, let's import UIKit instead. Class router. Let's hold a reference for the navigation controller that we are going to use in this application. And now we're going to have to extend our router by conforming to the detail navigation protocol that we just created. So let's do this extension router that conforms to detail navigation. This is going to be a discardable result. Okay. Func navigate to detail. Okay. So this requires us to create an instance of the detail view controller, pass in the integer parameter used before, and push the view controller to the navigation stack. So let's create the view controller. Detail view controller. It takes the integer, the item ID. Let's now push self navigation controller Push view controller, animated, yes, of course, true. And let's return the view controller. So what is missing is to link everything by creating an instance of the router. So let's go back to the scene delegate where we're going to see this error here. So let's create the router instance and pass it on the root view controller's initializer. So it expects in Navigator, which is now our router. Let's do router.navigation controller and hold this reference down here, navigation controller. So now let's run and check if the navigation to the details screen works by having the view controller push the navigation stack. So let's run the app. Okay, so let's tap on go to details and it works. Cool.
We should now focus on reproducing this to our app's listing controller. As we did for the detail navigation, let's create a new protocol called listing navigation. We need to describe the navigate to listing function with no parameters in this case. Now in the router.swift file, the router should implement this protocol in order to define how the navigation will happen. We conform to the listing navigation that we've described by implementing the navigate to listing function, where we create the listing view controller instance and push it on to the stack. All that's left to do is to replace the old navigation on the root view controller with a new one using the router. First, we need to add a new protocol to the Navigator by using protocol composition. As we've changed the Navigator type, we must also update the root view controller initializer. Now we can check that the amazing Xcode autocomplete already provides us with the new navigation for the listing when we try to use the Navigator. We should check that everything is working as expected by running the app and showing both navigations working. Still, something is missing. The navigation to the detail page coming from the listing page is still using the old implementation. We could also fix this. First, we need to inject the Navigator to the listing view controller by defining an unknown property for holding the reference to the Navigator itself. In the did select row, let's use the new Navigator to implement the navigation. As you can see, we were able to easily reuse the navigation that was previously implemented. If we try to compile the code, we see that we get an error where we create the listing view controller. That happens because we are not passing the router on the initializer. Let's again check if everything is working as expected. We run the app, move to a listing screen, and again move to the selected detail screen. Great, we can now see our navigation working properly.
Thank you, Francisco. So let's recap. We started by creating a router entity that implements the multiple navigations that happen in the app. Each view controller declares where they want to navigate to, which will be handled by the router. And this way, the view controllers define where they want to navigate to, but they aren't aware of the implementation at all. Also, by having the navigation implemented in a separate layer, it is easy to reuse that code throughout the whole application and make it testable as well. So by iterating the first version of our router, moving from a strictly typed to a strongly typed approach, we managed to eliminate possible bugs cached only at runtime to the compile time moment. And now bugs tend to be centralized in a single point in our code base, making it easier to reason about them. Using protocol composition, we are able to swiftly adopt new existing navigation in a new view controller later down the road with a low entry effort.
Obviously, this pattern is not a silver bullet approach, but it allowed us to scale our app work with distributed teams in a low-friction environment, and maintain custom navigation logic and behavior in a single place.
We hope that you found this video useful for you and your team, and we hope to see you in the next episode of FARFETCH MOBCAST. Thank you.
Ciao!